Hi, I'm Mark Neyrinck. I'm an Iker Basque Fellow at the University of the Basque Country in Bilbao, Spain. So I'm going to describe to you how intergalactic filaments spin. First, I'll say something about origami, which oddly enough was a motivation for this study. Here we see a dark matter sheet that is folded up in phase space into a cosmic web. Origami, or a structure formation model where the dark matter sheet folds but does not stretch, is quite approximate, but still surprisingly relevant. The simplest way to make a node like a dark matter halo in origami is called a triangular twist fold. At left, here's a single node, and at right, a void inside a hexagon of halos. In 3D origami with the 3D sheet, which is hard to visualize, nodes are tetrahedra joined by triangular Toblerone prisms. In this approximation, nodes spin if and only if the filament joining them is also spinning. Since halo spins, this suggests that filaments do too. Of course, there are other reasons to associate spin with filaments. Halos near filaments tend to have their spin axes aligned or perpendicular to them depending on the mass. And filament cross-sections show a quadrupolar vorticity pattern, and essentially all objects are capable of spin, especially dreidels now. Why not filaments? The question is really, how much do they spin? And the answer is generally quite a bit. They're also, interestingly, I think, arguably the longest coherent objects in the universe that spin. Here we show a bunch of comets flying along streamlines in and around a filament in a smooth version of the illustrious simulation. So we find that filaments generally coherently rotate along their axis. This is a stack of many filaments between millennium halos, orienting each filament in the stack to spin the same way. Note that Jean-Louis Jade, the first author, is applying for postdocs. So previous work on this spin field around filaments has emphasized this quadrupolar pattern, but we find that the monopole, or simply the spin, is comparable to or higher than that. So panel A here is the stacked cross-section between halos, the horizontal axis lining with any walls. And the spin plus an anisotropic quadrupole, that's panel B in the middle, dominates the right panel, the quadrupole by itself, or the anisotropic pattern by itself in C. So this is a plot more quantitatively from the illustrious simulation. So here we also see that the monopole is comparable to or higher than the quadrupole. So filaments fold up with like origami twist folds with non-zero spin. Thank you and reasonably happy holidays.